everybody. Welcome to Taproot TV. My name is Barb Carr, and I'm here with System Improvements President Mark Paradise. And he wrote a really interesting blog post the other day about the scientific method and root cause analysis. So we invited him to talk about it today. So welcome, Mark.
Thanks, Barb. Glad to be here. Let's see, where should I start? I guess the scientific method. What is it?
Yes, what is it?
What is it? That's a good question. When I went, somebody told me the only way to do root cause analysis is a scientific method. And so at first I thought, well, I understand the basics, I think, of the scientific method. I mean, it's the old have a hypothesis and then verify the hypothesis. But I thought I'd go online and check, and so I did a Google search of scientific method, and I didn't realize there were so many different opinions as to what the scientific method is.
And what did you find out?
Well, there's lots of stuff beyond. I would just say everybody else should do a Google search too and see how many methods there are that claim to be the scientific method. But it does basically come down to have a hypothesis and verify the hypothesis. And some people say that goes all the way back to the Renaissance. It really got us out of the Dark Ages and into modern science, away from things like witchcraft and other kinds of I think this is, therefore it is, to where you had to be able to prove what you said, and it should be repeatable science. And really that's been a pretty good scientific basis. Some people say that the actual terminology wasn't even invented until the 20th century, so it's been around about 100 years. And it's not a bad thing. It just isn't good for root cause analysis. And so why would it not be good for root cause analysis? Why would you say, no, don't use the scientific method? And the answer is, first off, the scientific method has its flaws. Recent studies have shown something called confirmation bias gets in the way of doing good science because scientists want to prove what their hypothesis is. And so they prove what their hypothesis is, and humans have an actual, I don't want to say this, they tend to try to prove what they believe and ignore everything else.
Right.
And it's human nature. It isn't you can, Barb, be more careful next time. Don't be so judgmental about your hypothesis. In fact, what you should do is you should consider all the facts. Well, that's one of the problems.
Right.
So you take something like, what's a good example? Isaac Newton. Isaac Newton, famous mathematician, one of the greatest mathematicians of all times.
Yeah.
Supposedly, an apple fell on his head and he invented gravity. And if you take it a little bit more scientifically, he came up with mathematical formulas that were called the universal law of gravitation. Universal law of gravitation works everywhere. And for planets circling the sun, maybe that worked just fine.
Right.
But when they came up with something Newton didn't know about, subatomic particles, all of a sudden the universal laws of gravitation weren't universal. They didn't work anymore because now we're working with forces that Newton didn't realize existed. And so Newton's original mathematic formulas work for planets circling the sun, but don't work for subatomic particles. So even though he proved his hypothesis, it wasn't near as universal as he thought because there were things that he didn't know about.
Right.
He didn't know about subatomic particles, therefore he couldn't include them. So now what does that got to do with root cause analysis? People, when they have a hypothesis of what caused the accident, there are things they don't know about. And in a lot of cases, it's human factor stuff. In our courses, we used to sit, one of the first questions I used to ask in our 5-day courses was, how many people here have been trained in human factors, some kind of training in human factors? And less than 5%, a lot of times only like one person in the class usually had ever had any training in human factors. And then I'd ask, well, how many people here have been asked to investigate accidents and incidents where there was human error involved? And almost everybody would raise their hands.
Yeah.
So if they don't know anything,
there.
if they don't know anything about it, how are they going to prove their hypothesis?
Right.
They don't have the knowledge to do it. It's like Newton trying to come up with what are these forces on a small scale that he has no idea about. You can't do it. So luckily, we didn't start with the scientific method as our basis for inventing Taproot. I'm more of an engineering kind of person, and we started off thinking, how do you help people find the root causes of accidents? And we came up with a system that has expert system guidance in it to help guide people to the root causes of human performance problems. So the universal counter argument I could get from somebody is, well, what do those Taproot people know? How do they know what all the causes are? How could they possibly make a system that could find all the causes? And that's a good question. And I don't think we can claim to find all the causes, but what we attempt to do is give people guidance so that they can find a large majority of the causes, almost all the causes. And when we started doing this, when we started developing a system this way, I had a really good educational background in human factors and engineering and high reliability systems to get a first cut on this system, but we didn't stop there. First, I started with a small group of engineers and other people who did investigations. They did reviews. Then I reached out to experts really all over the world to do peer reviews of what I was doing, so we got their feedback. And each time we had another round of feedback and people reviewing this, they added ideas that became root causes on the root cause tree. And then since we've come out with the original system after we did the original research, we've had tens of thousands of users all over the world apply this and provide their feedback and provide their ideas of either things they found that weren't on the tree, they thought they found that weren't on the tree, or things that were, what do you want to say it? They couldn't really figure out what they were. Hey, I've got this problem and I can't understand what's causing this issue. Can you help us? And a lot of times it came up with, we ended up putting a new sentence in the dictionary or something else to help people find where they needed to go inside the tree, because it was already there. They just couldn't navigate their place to there. And so we've had 30 years now of improving Taproot and making it better and better. And so we don't say we found all the root causes that could exist, but we find many more than people have in their heads, and therefore it provides good guidance for folks to go find root causes, which doesn't exist in make a hypothesis and then you're going to try to verify the hypothesis. So other people say, well, what if I'm a really smart person? What if I'm really smart and I know lots?
I have lots of experience.
Exactly, I have lots of experience. Why can't I do the hypothesis method? And well, the first reason is because you have confirmation bias, and the smarter you are, the more of it you have, because the more you're convinced that your answer is right. And the second reason is, even the smartest person has their, what I would call, favorite causes. And so they tend to go out and look for the things that they tend to look for. And once again, that's almost confirmation, the definition of confirmation bias. And so they tend to find what they want to find. And the funny story, I knew a guy who was on the first shuttle accident, Presidential Commission investigation. He was a consultant to it. And one of the other guys was a consultant to it too, and he was the human factors consultant to that. And his specialty was sleep deprivation. And which is an interesting specialty. So what did he look for when they did the investigation? He looked for sleep deprivation, and sure enough, he found sleep deprivation was an issue for the managers making decisions. And I always thought that was funny. You know, you look for what you're good at, and you find what you're good at, and you might miss the other things that you're not an expert in.
I have a question to go back to for people that are viewing that are not familiar with maybe Taproot and some Taprootese terms. Tell me again about, you said that Taproot is based on 30 years of research, and then you mentioned the root cause tree and the root cause
30 years of use.
30 years of use and research. So the root cause tree and the root cause tree dictionary, how does that help a user go beyond their own knowledge? How do those tools help?
Okay, so first and foremost in Taproot, you've got to draw a snap chart. And the snap chart puts all the information you know about that investigation in a timeline so that you can understand what happened. So you start out not by trying to find out why it happened, but you're trying to find out what had happened. And so you take away I'm trying to verify my hypothesis, and you're just trying to find what are the facts. What are the facts, ma'am? What are the facts? Just want to have the facts. So you just lay out what the facts are, and you let the facts tell the story.
So that's the first step.
That's the first step. So you
bias.
don't have confirmation bias because you weren't trying to confirm anything.
Right.
You were just saying, here's the facts. And once you get the facts laid out, then you try to identify, well, what were the problems, the causal factors. Once you have those causal factors, then you step back and you say, okay, what do we know about this? Where can I go? And that's when you start using the root cause tree. And it even starts out, if it's a human performance problem, with 15 questions. And those questions, which are backed up by the dictionary with even more questions, once again, it's a questioning process, not a try to verify process.
Okay.
And so once again, you're using a process of elimination and selection to say, oh, that is a problem, oh, that's not a problem, based on the facts you collected up here on your snap chart. So everything goes back to you have to have facts, and everything goes back to you're trying to verify what those facts are and where they lead you through the tree. So number one, the first way it helps you is the 15 questions help guide you to what kinds of things you should be looking for that could cause human error.
And these are all human performance difficulties?
Right, because you're in the human performance difficulty section of the tree.
Right.
The equipment side's over here. We won't talk about that today, but we're going down the human performance section of the tree. Secondly, you go to the back side of the tree, and that's where you start getting more specific into particular topics. And once again, you're using the guidance of the questions in the dictionary to help you say, is that an issue or is that not an issue? And for each one of those you say yes to, there should be a fact back up there on your snap chart that says this is why I said yes to this question. So once again, you're letting the facts guide you to what possible things could be causing problems. So I guess that's why it's a little bit different process. It's not just a pick list. It's not just you're trying to verify what you think caused something. It's you're letting the facts lead you with a questioning process to try to help figure out what happened and why it happened.
The main difference, you think, with Taproot and...
Well, almost everything else, and basically the scientific method guys, they're really doing cause and effect.
Yeah.
Because what they're really trying to do is they're really trying to come back and say, here's my hypothesis, but it's in a cause and effect chain. And they're trying to verify that cause and effect chain. And we've done tons of things before about why cause and effect has problems, but Taproot really leads you through that without saying you have to make a cause and effect chain, without saying you have to make a hypothesis. You're letting the story get told, and you're really trying to go back and collect the facts, which sort of leads right into your evidence collection course and stuff of you got to have good evidence.
Yes.
If you don't have good evidence, you can't draw a good snap chart. And once again, if you're not using evidence to draw your snap chart, then what you're doing is you're saying, I believe this. You're making a hypothesis, and that's what you're trying to get away from.
Yes, I think it's very difficult not to want to draw a hypothesis, or it's difficult to overcome confirmation bias, just in any kind of...
Well, okay, so everybody, when they first tell you the story of the accident, they tell you, well, this is what happened.
Yes.
But as an investigator, what you have to do, and what you teach in your course, is you've got to step back from that and say, well, this is what we've been told. Now let's go out and collect the evidence that really, does this really what happened, or is it not what happened?
Right.
What evidence can we gather? And there's physical evidence you can get. There's people's stories they tell you, which may or not be accurate. There's recordings and all this other stuff. Maybe there's videos. Maybe somebody took videos going on. So there's all this stuff you can put together in your evidence package to get your snap chart to go from what I'd call little dotted circles and dotted lines of you suppose or you assume this happened to actual facts, and here's why it's a fact. Here's the evidence I have that proves that that's what happened. And so that's your whole drawing a snap chart, is getting facts to deal with rather than assumptions.
Yeah, that's good advice. How would you recommend for someone who is interested in learning the Taproot process, the first class, what do you think they should take first?
Okay, so it's a tough one. The course that's the shortest. So if you're thinking, well, gosh, I don't want to invest a bunch of time. I just want to get this. I want to see if this works or not. Would be the 2-day course. But the 2-day course doesn't really teach you everything you need to know for big, major investigations. So if you're somebody who does a lot of big investigations, or you want to dig more into the human factors of stuff, I'd say to go to the 5-day course. If you can afford the time right off the bat to go to a course, I'd recommend going to a 5-day course. And if you're somebody out there who's never done this before and doesn't know anybody using Taproot, go to the 5-day course and then go back and apply this and see how it works. That's what I always tell people. They say, well, what's your proof this works? I said, it doesn't make any difference what proof I say there is.
Yeah.
You take it home, you use it, and see if you and your boss don't agree that you're finding root causes that you previously didn't find, that you're developing corrective actions that you previously wouldn't have developed and are much better, much more effective, you think, than they would have been in the past. And when you do that, you'll go, well, I now know why I'm going to use Taproot, because you'll have proven it to yourself.
Yeah. That's good. That's good information. I hope that you all can check below this broadcast. We have a link to Mark's recent article for more information. And did you have anything else you wanted to add to that?
I should do it for today.
Awesome. Well, thank you so much for joining. I know you're really busy, so I appreciate you being here.
Everybody's really busy. There's nobody who isn't really busy nowadays. Everybody is very busy.
And it's been a great discussion. Please leave your comments, or if you have questions, we'll be checking our Facebook, and seeing if we can answer any questions for you. And we look forward to seeing you all again next Wednesday. So
Thanks.
Have a good day.
See you later.
Everyone. Bye-bye.